Woo! There you go. Now I'm
Gotta
recording.
start
Good.
all over again.
Good call. We're fine. I was just going over what an ellipse was. There you go. Boom, boom, boom. All right. Good call. I always forget to do that. Good thing there's videos recorded already, though, right? Okay. So just like I said, going over the components of an ellipse, major axis contains the vertices and the foci. The minor axis is perpendicular and contains the minor points. The vertices, 2 points of intersection of the ellipse and the major axis. So again, the length of an ellipse is from one vertex to the next. The foci are 2 fixed points of the ellipse. And the distance, once again, the distance from vertex 1 to vertex 2 is the length of the major axis. So here we will analyze the ellipse with a center at the origin, and the major axis is the x-axis. Looks like there's a lot going on here, but there is something to keep it really, really simple, and it's what I wrote below. So if you want to find the distance from the center to the vertex, that is always going to be represented by A. So A represents the distance from the center to the vertex. B represents the distance from the center to the minor points, and C represents the distance from the center to the focus. And if you need to find any of the components of your ellipse, then we get to use this lovely equation right here, which is based off the Pythagorean theorem. Just, of course, written differently from this triangle here. Because if you rewrote this, it would be b squared plus c squared equal to a squared. But this formula just automatically rearranges it for b squared. I have no idea why. I just noticed that. So honestly, you can use this and rearrange it to however you need to. Okay, I'll make that neater. Let's see. So this would be b squared plus c squared equal to a squared. And of course, you can rearrange it to solve for whatever letter we need to find, whatever important piece. Okay, so if our ellipse has the major axis on the x-axis, then this is the equation we will be using. X squared over a squared plus y squared over b squared equal to 1, where a is greater than b, and both a and b are greater than 0. All right. So let's go ahead and try this out. And your center will be at 0, 0, foci negative C0, positive C0, vertices negative A0, positive A0, 0, negative B, and 0B for your axis, minor axis points, or minor points as they're called. Okay, so for the first problem, it says find an equation of the ellipse with the center at the origin, one focus at 3, 0, and a vertex at negative 4, 0. So we want to find all the pieces of this ellipse. So one of the best ways to do it is just like we did with parabolas. We are going to graph all the points. So find an equation. We have a focus at 3, 0. So I'll go ahead and plot that. Here's my focus. I'll say focus 1. And then I have my vertex at negative 4, 0. So we'll go ahead and plot that. Negative 4, 0. So 1, 2, 3, 4. There's my vertex. And now there's one thing we know for sure. Did I plot that right? Yeah. Negative 4, 0. And then 3, 0. Yeah, we're in the right
Looks right.
place. Yeah. Okay, perfect. So one thing we know for sure is that the distance from vertex to focus is represented by C, right? Is that what? No, from center to, sorry, rewind. The distance from center to focus is represented by C, and the distance from center to vertex is represented by A. So we are saying our center is at the origin for this problem, which is right there. So this means, what is the value of A going to be? How many spaces away is the vertex from the center?
4.
4. Good. And how many spaces is the focus from the center?
3.
3.
3. And now all we have to do to find B is use that formula. So we're going to use B squared equal to, what was it? A squared minus C squared. And B squared is going to be 16 minus 9. And B squared is going to give me 7. Therefore, my minor point is going to be at the square root of 7. And since we're graphing these, we're actually going to want to know the exact number. So what is the square root of 7?
40.
2.65. Rounded to 2 decimal places. Okay, so if you know A, B, and C, then you can definitely graph the rest of your parabola. Because if I have my first vertex over here, then from my center, how do I find my other vertex? How many spaces do I go to the right?
4.
4. There it is. There's vertex 2. And then if my first focus is 3 spaces to the right, where's my second focus?
3 spaces to the left.
3 spaces to the left. There you go. And there's focus 2. And then we now know the distance for my minor points. So from the center, we're going to go up 2.65 and we're going to go down 2.65. So 1, 2, I'll say 0.65 is there. 1, 2, and 0.65 is there. So there's my minor points. So look at that. If you know A, B, and C, then this means we can definitely graph the ellipse. And we can also find the equation of our ellipse. So I'm just going to go ahead and connect vertices to minor points. So, and don't laugh at my ellipses. Hey, that's not
Nice
bad.
diamond.
Thanks.
Ball.
It's like an old lemon that you left on your counter. Okay, so that being said, we know that this is an ellipse with the center at the origin and the major axis is the x-axis. And the reason the major axis is the x-axis is because it contains the points, the vertices, the center, and the foci. Okay, so for my equation, we know that this is x squared over a squared plus y squared over b squared equal to 1. So all you have to do is fill in a squared and b squared, and we have the equation. So you'll get x squared over 16 plus y squared over 7 equal to 1. There's our equation. And then the last piece we need to do is just fill out every single point that we know. So yes, they gave us the center, which is at 0, 0. And then my vertices
Negative
are
4, 0, and 4, 0.
negative 4, 0, and 4, 0. My foci are at
3, 0, 3, 0.
negative 3, 0, and 3, 0. And last are my minor points.
0, 2.65, 0, negative
0 and 2.65 and negative 2.65.
So,
All right. let's say, since we're doing negatives first, and 0. And 2.65. And there you go. And those are all the pieces. For my math lab, I think it sums up some of the points. So I think for that one, you could put as plus or minus 40. But I know it does it on some of them and others it does not. But that is how you graph an ellipse and find the given pieces. Any questions on that?
Nope.
Not bad, right? So again, if you know A and you know B and you know C, you know the rest of your ellipse. You know how to find all the other points. That's it. Nothing to it. All right. Good to move on. Yeah. All right. Cool. Okay. So on this one, they are giving us the equation of the ellipse, and they want us to find A, B, and C, and then graph everything and label everything. So first off, what's given? What, from this equation, what is the value of A?
A is 5 and B is 3.
A is 5 and B is 3. This means we have to find C.
C.
So remember, we can use, what was the equation? We can rearrange the other one, or, so we can use this one, or we can use that one, either way. So if I use either one and rearrange for C, we would get C squared is equal to A squared minus B squared. So we just rearrange that formula to find either A, B, or C. So once again, it's going to be A squared minus B squared. Or I guess you could just look at your values and see which one's bigger, because that one's going to go first when you square it. So let's say C squared is going to be equal to A squared minus B squared, and C squared will be 25 minus 9, and C squared will be 16. Therefore, C is
4 plus minus 4.
4. Plus or minus works. But if you know anything about right triangles, what's a special case right triangle? A 3, 4, 5. It's amazing, right?
Oh, yeah.
I forgot. I was like, oh, you guys taking pre-cal already? I was like, no, wait, this is pre-cal. Okay. So to find the rest of our pieces, let's just go ahead and graph. We will see 3, 4, 5 right triangles in chapter 7. Yeah, sure. I think chapter 7. Okay. So let's go ahead and graph our pieces. So we know our center is at the origin. And then, so there's my center. And then A represents the distance from center to vertex. So to find my vertices, how many spaces am I going to go out right and left?
5.
5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'll just call that vertex 1, vertex 2. And then let's go ahead and plot the foci. So C represents the distance from center to foci. So how many spaces are we going to go left and right here?
4.
4. There it is. There it is. And I have focus 2, focus 1. And then to find my minor points, we're going to go up and down how many spaces?
3.
3. 1, 2, 3. 1, 2, 3. There we go. Those are my minor points. And then connect your ellipse. Vertices to minor points. Hey, getting better. Missed that dot totally. Okay. And now they already gave us the equation, so we're just going to list everything that we know. So center is at 0, 0. Vertices, and I'm going to sum these points up now. Vertices are at plus or minus 5 and 0. Foci are at plus or minus 4 and 0. And minor points are at 0 and plus or minus 3. All right. Any questions on that?
Like, so when we have to graph this in my math lab, is it difficult to use the tool since it's?
I don't think so. Let's look. Let's see. I'll go to my assignment
It's pretty
manager.
specific on.
And then ellipse, I'll go to preview, and you can't see my screen yet, but that's okay. And if we're graphing, oh wait, I have to get through all that. Let's see, I'll just answer wrong real fast. Wrong, wrong, wrong. Keep answering wrong. Or is it gonna let you pick the graph? Let's see. It might just have you pick the graph instead of actually graph it. Yep. I think it just makes you pick them.
Cool.
Yeah. That's no fun. I guess it makes it easier though. Yeah. So it just makes you pick the graph. All right. Okay. Good with that. So those are ellipses with the center at the origin, and the major axis is the x-axis. And now we get into ellipses with the center at the origin, but the major axis is now on the y-axis. Okay. So with that, a couple things change. So, well, not a couple, probably just one thing changes, right? So still, A still represents the distance from center to vertices. B still represents the distance from center to minor points. And of course, C still represents the distance from center to foci. So one of the main changes since we flipped this on the y-axis is you have x squared over b squared now plus y squared over a squared equal to 1, where a is still greater than b and b is still greater than 0. And now we have a different formula of b squared equal to a squared minus c squared. Is that the same formula? That's the same formula. B squared equals that. So yeah, so once again, this formula is still b squared plus c squared equal to a squared, which you can rearrange. Okay, so the equation changes just a bit because now you see the denominator under x is b squared, denominator under y is a squared, and then your center is still 0, 0. Your foci 0 plus or minus c, vertices 0 plus or minus a, and minor points are plus or minus b. So let's go ahead and try these types of ellipses out. So for A, it says given 9x squared plus y squared equal to 9, put the equation in proper form, find A, B, and C, graph it, and list everything. Whew. Okay, so we're going to put this in its proper form. We just have to divide by what?
B squared and a squared.
Yeah, 9.
How about divide by 9? And this will give me, come on, computer, x squared over 1 plus y squared over 9 equal to 1. Here's the equation of my ellipse. That is going to be, that will have the major axis on the y-axis. So Now looking at that, what is the value of A and B?
I
1
have
and
a
3.
quick question.
What's up?
Okay, so the only time you're ever gonna be able to tell whether whether the vertices is on the y-axis or x-axis is if you know, so like if okay, you know how it's x squared over a squared and then y squared
Mhm.
over b squared. If it's ever, it depends on which side is the bigger number.
That's it. I was going to say, keep it simple like that. So depend
Okay.
whether to find out what axis you're parallel to or what axis you lie on. It all depends on who has the bigger denominator.
Okay, cool. Thank
That's
you.
it. All right. So now since this is the major axis on the y-axis, A is going to be 3 and B is going to be 1. Because we have to match it to the equation above that you see up there. So x squared over b squared plus y squared over a squared. And then to find C, well, we will just use that formula and we'll have C squared equal to a squared minus b squared. And C squared will be 9 minus 1. And C squared will be 8. And what is the square root of 8?
2
2 radical 2.
2 radical 2. But we need that decimal number in order to graph it.
Gross.
So we get about 2.83. Okay, so this means we're ready to graph. Center is at the origin. There's my center. Maybe I could just zoom in a tad bit more. Oh, I just need that, right? Center's at the origin. And now since we have a major axis on the y-axis, to find the vertices, how many spaces am I going to go above and below the center?
3.
3. So here is vertex 1, vertex 2. And then for my foci, why not? I'm going to go up 2.83 and down 2.83. So that's going to be really close to my vertices. So there's foci, let's say 2, foci 1. And then for my minor points, hey, I just go out 1 to the left, 1 to the right. And we have the tiniest ellipse ever. It's perfect. Okay. So now, again, just list everything we have. Center is at 0, 0. Vertices are at plus or minus, oh, nope, other way, right? 0 and plus or minus 3. Foci are at 0 and plus or minus 2 square root 2. Minor points are at plus or minus 1 and 0. And there you have it. Okay, and now that is an equation of an ellipse with the major axis on the y
Okay,
axis.
I think I kind of got something. So like basically it's just called the vertices because it's the point longest, right? From the center.
It's, yeah, from the point longest, and the vertices make up the endpoints of the ellipse.
Okay.
They are the length of the actual ellipse.
Yes, okay.
Yeah. Okay. Cool. All right. Go ahead. I'll give you like 2-3 minutes, go ahead and try this one out. So given a focus at 0, 2, vertex at 0, 3, 0, negative 3, find the equation of the ellipse, graph it, and label everything. So try it out, guys.
Do you think you could give me a decimal point for the square root of 5? Because my calculator, for whatever reason, is not able to do it.
Which calculator are you using?
TI-30XS Multiview.
So in order to change it to a decimal, you see the little double arrows above your enter button?
Yes.
Push that.
I've been looking for like how to do this for the longest time.
There you go. That's what I'm here for.
Yes,
Calculator help. Nice.
Cool.
All right. And there it is, y'all. All right. Any questions on these two? So these ones, pretty straightforward. Once again, they put the center at the origin and they give you the pieces. So if you know how to graph it and find your pieces, you'll be able to find the equation and everything else you need. All right. Everybody good? I see a thumbs up. Nice. Oh, another thumbs up. Yeah. Oh. Okay. Let's keep moving then. All right. So the last two were ellipses with the center at the origin. And now we're going to get ellipses with the center at HK, meaning we're going to move the center wherever we want it. So one of the ways to tell which equation to use is finding out what axis you are parallel to. So for the first picture, we see we have our vertices, foci, center. All of them on the major axis are parallel to the x-axis. So depending on the placement of your center, your vertices, and your foci, you can just, from the graph, you can see which axis they are parallel to. And if you are parallel to the x-axis, then this is the formula you are going to use. X minus h squared over a squared plus y minus k squared over b squared equal to 1. And I have that all listed down here for us to follow. So when we start attempting the next problems. Okay. And once again, there's nothing different from these than the last examples. If you know A, if you know B, if you know C, you can find everything you need to. Okay. And then for the next picture, we see we have the, again, vertices and foci, the center, but this time they are parallel with the y-axis. So again, placement matters. If you know where your center is, basically, if you, I guess, yeah, no, center, foci, vertices, if you know where those points lie, then you know which axis you can match them up to. You know which one you are parallel to. And if you are parallel to the y-axis, you will use this equation. X minus h squared over b squared plus y minus k squared over a squared equal to 1, which again, I have everything written for you down below. All right, so let's go ahead and try these out. There we go. So find an equation for the ellipse with center 2, -3, focus 3, -3, and vertex 5, -3. Graph the equation, list the center, foci, vertices, and minor points. So one of the easiest ways to start is by graphing what they have given to us. That is the easiest way to find our components. So I'm going to graph the center at 2, -3. There's my center. And then we're going to go with the focus at 3, -3. So 3, -3. Hey, there's my focus. And then my vertex at 5, -3. 1, 2, 3, 4, 5, -3. And there's my vertex. Okay, so we know some things already. Remember that A is the distance from center to vertex. So how many spaces away is the vertex from the center?
3.
3, which means, can we find the other vertex?
Yes.
Yeah, it's gonna be 3 the opposite ways.
Yeah, there you go. And there's vertex 2. And then C represents the distance from center to focus. So how many spaces away is that focus?
1.
Yeah, 1, which means we can find the other focus, which is right there. Focus 2. And then something really important. Remember that this is the major axis. So one thing we want to note right away is what axis are we parallel to?
The x-axis.
Good. So I'll write that down here. Parallel
So
to
you
the
can kind of tell
x-axis.
that already from your vertices, right? If they're going up and down, they're going to be parallel to the y-axis versus left and right, they're going to be parallel to the
Exactly.
x-axis.
Very good. I mean, you could probably notice it right away, right? So it's just on the placement of your main points, vertices, foci, center, just wherever they're placed, you can probably tell what you're going to be parallel to. Okay, so let's go ahead and find B. It's going to be a squared minus c squared, and b squared is going to be 9 minus 1. And hey, this looks familiar, right?
2 square root of 2.
Good. And b is 2 square root of 2, which was what decimal number?
2.83 if we're only going to 2 decimal places.
Yeah, 2.83. There we go. So we have our minor points now. So I'll just go up 2.83, 1, 2, probably around there, and then down 2.83, 1, 2, and go right there. So there's my minor points. And connect. Ew, almost. Nope, not any better. See if I can do better. Probably not. No, look better than the last one. Okay, perfect. So we have a bunch of our components. We have our center. So this means, and we know we're parallel to the x-axis. So this means we can actually find our equation right now.
Well,
So
we'd be using the x minus h squared over
Very-
h squared, right? Rather than over b squared.
very good.
And
So-
is this equation still equal to 1? It is, right?
Yeah.
Okay, cool.
Still equal to 1. Was that not on there?
No, I think it was.
Ah.
I forgot. Sorry.
No, you're right.
Was? Whoa.
It's missing. What? Good call. There we go. All right. So the formulas are there. Since we're parallel to the x-axis, we know we're going to use that formula. So let's go ahead and fill in what we know. So we're going to have x and minus 2 squared.
I have a quick question.
Mm-hmm.
Okay, so we're plugging in the Wait, we would plug in the center as HK. The center is HK.
Exactly.
Okay.
Center,
Yes,
yeah.
I was
Good.
gonna ask which vertex we would put in, but center is HK.
Gotcha. And then over b squared, which is 8, equal to 1. All right. That is the equation that represents this ellipse. And now, once again, just label everything we have. Center's at 2, negative 3. Vertices are at, and how could I shortcut this? Or maybe not. 5, negative 3, and negative 1, negative 3. No shortcutting that. 5, negative 3, and negative 1, negative 3. And then, right, and then foci are going to be at 3, negative 3. And what's that? 1, negative 3. And then last is my minor points, which are ugly. So here's how we're going to write this. And they only went up and down. So it's going to be 2 and -3 plus or minus 2 square root of 2. There we go. And I think you can leave it like that. If not, put it as a decimal number and add 3. All right. Any questions on that one? Oops. All right, I guess we're good then, right? Let's keep going. Hey, what's this? Last one? Sure is. Okay. So again, I have the formulas for you above there. And now we are actually given the general form of an ellipse. So we need to take the general form of ellipse and put it into its standard form. And then graph everything, list everything, and have fun. So let's go ahead. Let's go ahead and rewrite this. So I'll put my terms together. 4x squared and the 8x, and then y squared plus 4y. And what am I going to move over to the right?
Either X or
Four.
Y, and probably X.
4.
The 4. We're going to move that 4 over.
We wouldn't move the other.
No, because remember, if we're creating the equation of an ellipse, it's
Oh,
gonna
okay.
it's gonna be in that form, right?
Yes, sir.
Yeah. Okay. So we keep the x and y's on the same side. Okay. Well, then what we're gonna do next, so to create the equation of this ellipse, well, we're gonna do what we did on the last two with parabolas and circles. To create the equation of ellipse, we have to complete the square, right? So before I complete the square on these x terms, what number do I need to factor out of there?
4.
A 4. So I take this 4 out, and I'm left with x squared minus 2x plus y squared plus 4y equal to -4. Okay, we are now ready to complete the square. We'll start with this one. So I'll say complete the square. And of course, we're going to take half of -2 and square it.
It's -1 squared.
-1 squared, which gives me 1. Okay, and then let's go ahead and look at this one. And if we complete the square on that one,
+4.
take half of 4, square it, and we still get 4, right? Okay. So when I rewrite this, I'm going to have 4 times x squared minus 2x plus 1 plus y squared plus 4y plus 4 equal to -4 plus, I guess I should put these in different colors. One moment. This will be my 1, and here will be my 4. And now what number is going to go next to this -4?
Would it be
1
1 and 4?
and 4.
Or 5?
Careful. So normally it would be a 1, but what number is waiting out here?
Okay. Multiply it by 4.
So you have to multiply it by 4. So
So-
there's going to be a 4 here instead of a 1. If that 4 wasn't there, then yes, you would be correct. It would be a 1. But since that 4 is waiting on the outside, you have to multiply that 1 by the 4.
That's tricky.
That's tricky. Yes, for sure. But it's part of the completing square process, right?
Yes, sir.
All right. Because remember, quick lesson here, right? When you completed the square, it would be 4 times x squared minus 2x plus 1 minus 1. And then you would separate it as 4 times x squared minus 2x plus 1. And then out here, well, actually, like this. And then you can separate the minus 1 out there. And then that 4 would distribute here and there. And therefore giving me 4 times x squared minus 2x plus 1 minus 4. And then this minus 4 becomes that plus 4. Oh my goodness. Did you guys even know that was going on in there?
Oh, algebra back at us again.
Always. Okay. So that was just a small completing the square lesson, right? And now we know after we complete the square, you get trinomials that become factorable. They are perfect square trinomials. So all of this is going to factor to what?
X minus 1 squared
Plus
Minus 1 squared, and then it's y
plus 2, y plus 2 squared.
equal to
1, or well, equal to 4, but then you divide the 4 and then you get x minus 1 squared over 1 plus y plus 2 squared over 4 equals 1.
Whoa, bro. Yeah, you got it. All right. All right. X minus 1 squared over 1 plus y plus 2 squared over 4 equal to 1. There you have it. Read it and weep, but don't weep. Okay.
Not gonna lie, this is like super fun.
Okay. So now, match this formula or equation to the ones above. What are we going to be parallel with?
The y-axis,
Why?
because 4 is the larger number, and the larger number is always a.
All right. Good.
Is there another way of telling that, or is that just the rule? Like that's just how it is.
That's just how it is with the ellipses. So it's whatever denominator is bigger, it's going to tell you what you're parallel with. Okay. Well, then let's go ahead and figure out what we need to graph this. And what is my value of A going to be?
2.
2. B is
1.
1. And then now we have to find C. So it's A squared minus B squared. And you get 4 minus 1.
Radical 3.
Which gives me 3. And C is radical 3. But we need that decimal number. .73. Okay, perfect. So now, what is my center?
Well, first off, we should graph the points to help us find it.
Well, our center is given away by the equation, isn't it?
1, negative 2.
Yeah, 1, negative 2.
There you go. 1, negative 2. There we go. There's my center. And since we know we're parallel with the y-axis, we can go ahead and plot the vertices, the foci, and the minor points. So let's start with the vertices. How many spaces am I going to go up from the center?
2.
2. There's my vertices. Vertex 1, vertex 2. And for my foci, ew, that's gross, right? 1.73. That's going to be like right there and right there. Let me zoom in a bit on my graph. There we go. And then those are my foci. So foci 1, foci 2, and then my minor points, I just go right 1 and left 1. And there's my minor points. Connect, connect. And there we go. There's our graph. Now, all we have to do is label everything we have. One, -2. Vertices are at 1 and what's that? 0. And 1 and 4, -4. Foci are not nice. So we can say 1 and -2 plus or minus the square root of 3. And then minor points are at 0 and -2. And then 2, -2.
Why is the foci written like that? I kind of don't get it.
Because it's just me shortcutting it. I can write it like this if you want. 1 and -2 plus the square root of 3. Or I can even add that decimal number and make this 1 and what is that? -2 plus 1.73. So that'd just be -2 and
Well,
1 and -0.73.
where does the -2? Where did the -2 come from? It's kind of what I'm not getting.
From the center.
Okay.
Because for your foci, you're going up square root of 3 and you're going down square root of 3.
Oh, okay. Oh, okay. Gotcha. Okay, thank you for clarifying.
Yeah, for sure. All right, kids. And those are ellipses. I don't know how simple that could get, though, right? Just a bunch of basic algebra in there. Okay. We are done. So if you have any questions about the notes or the homework, please ask. If you don't, you're good to go.
All right.
Enjoy your weekend.
You have a great rest of your